Let's start with number 1 of the I've got to fill in activity. What we're given is y equals x squared minus x minus 12. This is in standard form, so we know that we have, ax squared where a is 1, bx where b is negative 1, and c where c is negative 12. They're asking us to put it in factored form and graph the equation. So to put this into factored form, all we have to do is factor x squared minus x minus 12. Because a is 1, all I need to do is find what multiplies to c but adds to b. So what multiplies to negative 12 but adds to negative 1? Well, we have 1 and negative 12, we have 2 and negative 6, and obviously we have negative 2 and positive 6 as well. We also have 3 and negative 4. I know that's got a difference of 1, so I think this is going to be my money. Here we also have negative 3 and 4. Which one of these adds to negative 1? Well, 3 and negative 4 add to negative 1, so those are going to be my factors. And this factors into x plus 3 times x minus 4. So my factored form of the equation is going to be y equals x plus 3 times x minus 4. The nice thing about factored form is that there are certain points that we can easily graph. I apologize that these are not straight lines, but it's very difficult on an iPad to make these. So work with me here. Make this a little bit better. There we go. All right, 2 of the points that we know we have are x plus 3, so we have an x-intercept of negative 3, so x equals negative 3, and we have an x-intercept of positive 4. So we can graph these points, 2, 3, 4, and we know that that's going to be part of our equation, part of our graph. The other thing we need to find really is the vertex. We can't tell the vertex from either of these forms, but one thing we do know is that the line of symmetry is halfway between the x-intercepts. So my line of symmetry, I'm just going to write LOS, is going to be negative 3 plus 4 divided by 2, which is going to be 1/2. So my x coordinate of my vertex is going to be at 1/2. I can plug this into my equation. I'm using my factored form here, but I also could use this one. So actually let's use what we started with. We have 1/2 squared minus 1/2 minus 12. Well, 1/2 squared is 1/4 minus 1/2 minus 12. You can use your calculator and put this in, but I'm just, because I don't have a calculator, going to make all my denominators the same. So I have 1/4, I have 2/4, and I have 12, 24, 36, 48 fourths. And 1 minus 2 minus 48, 1 minus 2 is negative 1, negative 1 minus 48 is negative 49 fourths. Well, 4 goes into 40 10 times. We have 2 more 4s we can put in, so 12, that's 48. So this is really negative 12 and 1/4. So I'm going to go to where my vertex is going to be 1/2, comma, negative 49 fourths, which is negative 12 and 1/4. So I'm going to go down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 1/4. I did not make my graph big enough, but that would be right there. You could also plot some extra points because you want to make a good graph. So you could put in, for instance, negative 1. Negative 1, I'm going to look at this equation right up here. Negative 1 plus 3 sorry, this is when x equals -1. -1 plus 3 is 2. -1 minus 4 is -5. So -1 is going to be -10. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's right here. Remember that a parabola is symmetrical. So we are at, I want you to see this, we're at 1/2. So this is 1.5 over. So 1.5 over would also be right here. Then also let's find x equals -2. We've got -2 plus 3, which is 1, and -2 minus 4 is -6. So this is going to be -6. We're going to have -2, -6. And I can plot that. 1, 2, 3, 4, 5. -6 is right here. And again, that's 2.5 over from the line of symmetry. So I'm going to move over, here's my half, and then 1, 2. So half, 1, 2, it's going to be right there. And that is probably enough points to make my parabola. Again, your parabola should look a little bit better than mine, but I'm working with technology. The next problem we have is a similar problem. So I want you to pause the video and try this one. Remember, in this case, you're putting it into vertex form, but you're still using some of the same ideas. All right, we have y equals x squared minus 6x plus 3, and this is in standard form. We're looking to find an equation in vertex form. So the easiest way to do this is to use our completing the square method. So I have my box, and I know I have an x squared, and I have -6x's. Because our goal is to get a perfect square with the same dimensions, we have to divide that evenly. So we're going to have -3x's over here and -3x's over here. This is going to give us dimensions of x minus 3 and x minus 3. And we know that -3 times -3 is positive 9. So what we have is x squared minus 6x plus 9, and what we want is x squared minus 6x plus 3. So how can we go from 9 to 3? Well, we can subtract 6, because 9 minus 6 is 3. So what we have is x minus 3 squared. That's what this equals. But then we need to take away 6 to get it to equal what we started with. So we're going to subtract 6. So y equals x minus 3 squared minus 6. This means we have a vertex at 3, -6, and it opens up. So my vertex form is y equals x minus 3 squared minus 6. And if I draw a graph, again, I apologize for the lack of straight lines. I'm going to draw my vertex in at 3, -6. So I'm going to count 1, 2, 3, and down 1, 2, 3, 4, 5, 6. So we have our point at 3, -6. Because there's no vertical stretch, there's a coefficient of 1, and we know that parabolas are symmetrical. We know that my next point is going to go up by 1 on both sides, because remember, our parent function x squared is 0, 0, and then 1 squared is 1, so we go up by 1. 2 squared is 4, 3 squared is 9. So we went up by 1, now we're going from the vertex up by 4, so 1, 2, 3, 4, over in both directions. And then we're going up by 9 from the vertex. 1, 2, 3, 4, 5, 6, 7, 8, 9 on both sides. So that is enough points for us to connect. Sorry, that was a terrible parabola. But you know what I'm trying to do. You get the point, hopefully. So that's number 2. For question number 3, we're given a graph, and we're asked to find the vertex form and the standard form. We don't have, we can make a table of values, but we don't have any equation to start with. However, we are very nicely given a vertex, and that vertex is 2, -3. So with 2, -3, we can put it into vertex form. We know our shell is going to be y equals a times x minus h squared plus k. And we know that our vertex is 2, -3. So we know that part of our equation is going to be y equals some number a times x minus 2 squared minus 3. Now we need to figure out a, and we have 2 ways to do it. Because we're given a graph and we know the vertex, I can look to see how my next value changes. And when I go over 1 to the right, it only goes up by a half. So I know that that actually is going to be my A. And it's positive because the graph opens up. So we know we're going to have a vertical stretch of 1/2. If I did not know the vertex, so let's say like in question number 4, if you look down here, you can see that you're given 2 points, but you don't know what the vertex is. I cannot use this method. So another method that I can do is I can take any other point on the graph. I like picking the y-intercept, which is 0, -1, and I can plug that in to my shell. So right now I know that my vertex form is y equals a, granted, yes, we just found that it was 1/2, but a times x minus 2 squared minus 3. Well, let's plug in a y value of -1, a, and an x value of 0, and solve for a. So we've got -1 equals a times -2 squared, which is 4, minus 3. So I'm going to add 3 on both sides. -1 plus 3 is 2, equals 4a, and when you divide by 4, a equals 1/2. So either way works. This way works all the time, but takes a little bit more work. This way only works when you know the vertex. Now we need to find our standard form. Our standard form is all we have to do is multiply out our vertex form. So y equals 1/2, and this is, remember, x minus 2 times x minus 2 minus 3. Don't try to distribute the 1/2 inside, it won't work. So y equals 1/2. I like to do the x minus 2 times x minus 2 first, which is going to give me x squared minus 4x plus 4. Remember, if you need to, you can do the box to figure this out. We have x minus 2 and we have x minus 2. X times x is x squared. We have a -2x, a -2x, and a 4. And we get x squared minus 4x plus 4. Then we have minus 3. Now, according to order of operations, I need to multiply out the 1/2. So I have 1/2 x squared. 1/2 times -4 is -2x. 1/2 times positive 4 is positive 2, and then I'm subtracting 3. So my final answer is going to be y equals 1/2 x squared minus 2x minus 1. For the next problem, number 4, you have to find the factored form. So there's many ways you can do this. I want you to try it on your own and try to think of the stuff I reviewed at the beginning involving x-intercepts, because that will help you. So pause the video now and try. Alright, I'm looking for factored form, and the best thing about factored form is if you know the x-intercepts, then you can do factored form. So here we have x equals 2, and we have x equals negative 5. These are our x-intercepts. Remember, factored form is y equals a times x minus p times x minus q. And these x-intercepts are always the opposite because I want to get it set equal to 0. So I know that what my shell is going to be is y equals some number a times x plus 5, because it's the opposite, and x minus 2. Now I still need to find a, and when I look at my vertex, I don't know what it is, so I can't sit and do the method that we did before. However, I can plug in a point. You never, ever, ever want to plug in the x-intercepts. Pick any other point on the graph, but don't pick the x-intercepts. So I'm going to pick my y-intercept, which is 0, 10, and I'm going to plug this point in. So I'm going to do my work down here. Y equals a times x plus 5 times x minus 2. And I'm going to scoot this down just a bit. We have y, which is 10, equals a times 0 plus 5 times 0 minus 2. So 10 equals a times 5 times negative 2. 5 times negative 2 is negative 10, so we have negative 10a, and divide both sides by negative 10, and we get a equals negative 1. And this roughly makes sense because looking at this graph, we know that it's got to be a negative number. It opens down. But we couldn't be certain about it being 1 or another number. So I'm going to put in my vertical stretch of negative 1. I can either write in negative 1, negative 1, or I can just put in a negative. So y equals negative x plus 5 times x minus 2. Now we need to write the standard form of this equation. So standard form, we can just multiply this out. Y equals negative, and then I'm going to have x plus 5 times x minus 2. I'm going to leave my negative on the outside for right now, and I'm just going to multiply x plus 5 times x minus 2. Again, if you need to use the box, you can. We have x in positive 5 and x in negative 2. So we get x squared, negative 2x, 5x, and negative 10. So what we have is x squared plus 3x minus 10. Now don't forget that we have this negative in front, so we need to distribute it. So our final answer is y equals negative x squared minus 3x plus 10. You need to distribute it to every single term inside. And this is our final answer. If I wanted to put this into vertex form, I would need to find the line of symmetry. And we can find the line of symmetry because remember, x equals p plus q divided by 2. And p plus q, that's negative 5 plus 2 divided by 2 is negative 3/2. Now, I need to plug in negative 3/2 into an equation. So it's always nice in a case like this where we don't know the vertex, find another equation first, like factored form, take your value of x, plug it in to find y, and then you can find your a, which we found this way. And that takes care of number 4. Last we have question 5 and 6, and these directly relate to the other video I made where you're converting from standard form to vertex form when a is not 1, when that leading coefficient is not 1. So notice in 5 we have a negative, and in 6 we have a 2. So we're going to do these problems. Number 6 is going to be very tricky because it deals with fractions. It's not a nice problem. So you really want to just focus on the ideas behind what I'm doing, but don't worry so much about the difficulty level. You won't have something like that on your test, hopefully. So number 5, y equals negative x squared minus 6x plus 16. In the previous video, which I hope you watched first, we have to always take out the leading coefficient. So what I have is y equals the negative, and then I need to divide each term by negative. So negative x squared divided by negative is x squared. We have positive 6x, and we have negative 16. Now, the question's asking us to do either form of the equation other than standard form. That gives us vertex form or factored form. Since it's asking for the vertex of the parabola, we might as well put it in vertex form. But if you want to put it in factored form, which I'm also going to do, all you need to do is factor this. All right, we have this negative, we took it out. So x squared plus 6x minus 16. I'm looking for what multiplies to negative 16 but adds to 6. Well, I've got 1 and 16, which I know won't work. I've got 2 and negative 8, or negative 2 and 8. Since I'm trying to get positive 6x, because I'm only focusing on what's inside the parentheses, we have negative 2 and 8. So standard form is going to give me the equation y equals negative x minus 2 times x plus 8. Let's focus on vertex form, which is a little bit more complicated. I need to do completing the square to what's inside my parentheses. So I have my box. I know I have an x squared, and I know I have 6 x's, which I need to distribute evenly because we're making a square which has the same dimensions. So I'm going to have 3x and 3x, which is going to give me sides x plus 3 and x plus 3. This means 3 times 3, my last box is going to be 9. So this gives me x squared plus 6x plus 9. But I'm trying to get to x squared plus 6x minus 16. Well, negative 16 minus 9 is negative 25. So what we need to do is we have our x plus 3 squared. That's what this equals. And then to get to this, we have to take away 25. So we're going to have minus 25. Now, where it gets tricky in this vertex form is that what I now have is y equals the negative of x plus 3 squared minus 25. I have to redistribute that negative into this equation. If you remember, we can't distribute it inside of this binomial, we just leave it on the outside. But then we also distribute it to the negative 25. So my final vertex form will be y equals negative x plus 3 squared plus 25. And then from that, we can see that our vertex is going to be negative 3, 25. All right, finally we have question number 6 and 7. I'm sorry, I think I told you earlier that 6 was going to have a lot of difficulty, but it's question number 7. So I want you to pause the video and try number 6. All right, with number 6, we have y equals 2x squared plus 12x plus 13. If we want to factor it, we multiply 2 times 13, which gives us positive 26. So our factors are 1 and 26, 2 and 13, 3 doesn't go into 26, 4 doesn't go into 26, 5 doesn't, 6 doesn't, 7 doesn't, 8 doesn't, 9 doesn't, 10 doesn't, 11 doesn't, 12 doesn't, and then 13 does, which we have already. So 1 plus 26 is 27, 2 plus 13 is 15. Nothing is going to add to 12x, which means this is not factorable. So the only form that we're going to put it in, that we can put it in, is vertex form. So we're going to try again. We're going to pull out our leading coefficient of 2, and we have x squared plus 6x plus 13 halves. All right, I'm going to make my box. I have my x squared. I have 6 x's, which I need to distribute evenly, so I have 3x and 3x. And that's going to give me sides of x plus 3 and x plus 3. 3 times 3 is 9, so 9 goes in the box. So what we have is x squared plus 6x plus 9. But what we want is x squared plus 6x plus 13 halves. So I need to do 13 halves minus 9. And you can do this in your calculator or 13 halves and then make 9 a denominator of 2. So I'll have 18 halves. 13 minus 18 is negative 5, so I'm going to have negative 5 halves. So I have to subtract 5 halves in order to go from x squared plus 6x plus 9 to x squared plus 6x plus 13 halves. This is going to simplify into x plus 3 squared minus 5 halves. So my vertex form is going to be y equals, now remember we just did what's inside the parentheses, so we have 2 times x plus 3 squared minus 5 halves. We need to multiply out the 2, but remember we don't distribute it to what's inside the binomial, so we have y equals 2 times x plus 3 halves, and then 2 times negative 5 halves is negative 5. And that is our vertex form. So the vertex is going to be negative 3, negative 5, and my y-intercept is when x is 0. I can just take my standard form, and if you remember, this is going to be 0, 0. My y-intercept is just going to be 13. So I can write y equals 13 as my y-intercept. All right, finally we have question number 7. If you want, try this one on your own, but beware that it gets a little more complicated with the fractions, or you can just watch and try to follow along. So I see that we have y equals negative 2x squared plus 14x plus 60. So it says to write either form of the equation other than standard form. One thing that I notice is that I can take out a negative 2. So y equals negative 2 times x squared minus 7x minus 30. I'm going to look to see if I can factor this one first. So what multiplies to negative 30 but adds to negative 7? Well, I know I have 1 and negative 30. I have 2 and negative 15. I have 3 and negative 10. And I can see that 3 and negative 10 will add up to negative 7. So my standard form is going to be y equals negative 2 times x plus 3 times x minus 10. Now let's try to find vertex form. This is where I was talking about the fractions getting complicated. Vertex form is going to require us to complete the square with the binomial. We've got our box, we have x squared, but then we have negative 7x's. Since that is an odd number, we have to divide it evenly. So negative 7 divided by 2 is negative 7 halves x and negative 7 halves x. This is going to give us sides of x minus 7 halves and x minus 7 halves. Well, to find what's in this box, we have to multiply negative 7 halves times negative 7 halves. We multiply the numerators together, so negative 7 times negative 7 is 49, and 2 times 2 is 4. So what we're going to have is 49 fourths. This is going to factor into x minus 7 halves squared. It also gives us x squared minus 7x plus 49 fourths. What we want is x squared minus 7x minus 30. So you can use a calculator and do negative 30 minus 49 fourths, but as I've said, I'm going to do it by hand, so we need a denominator of 4 that equals negative 30. Well, negative 30 times 4 is negative 120, so negative 120 fourths equals negative 30. Then this is minus 49 fourths. Subtract the 2, we have negative 169 fourths. So to go from what we have, which is the perfect square, to what we need, which is the negative 30, we have to subtract 169 fourths. So, what we have for our vertex form is going to be y equals negative 2 times x minus 7 halves squared minus 169 fourths. We need to multiply out the negative 2, but again, we cannot distribute it to inside the binomial. It stays on the outside. So negative 2 times x minus 7 halves squared, and then I need to multiply negative 169 fourths times negative 2. Well, I've got two negatives, which make a positive, and I've got a 2 on top and a 4 on the bottom, so I can take that into 1/2, and this is going to give me positive 169 halves. Therefore, we can see that our vertex is going to be 7 halves and 169 halves. And then we can find our y-intercept by looking at our standard form, which is going to be y equals 60. So that completes this I've got to fill in activity, and hopefully it clears up some of your misunderstandings.